Here we're going to look at creating a linear system to model a situation. So the situation we have here is a school has raised $140 by collecting 2,000 cans and bottles for recycling. The school receives 5 cents for a can and 10 cents for a bottle. So what we want to do is we want to create a linear system that's going to represent this situation, and then we have some numbers to verify using our linear system. So the school collected 1,200 cans and 800 bottles. We're just going to use those two numbers to verify that our system is correct. To help us create a linear system, we can create a table. So what this table will help us do is it'll help us organize our information so that it is a little easier to understand. Sometimes getting information from text or words is a little bit more difficult than maybe just seeing it on a chart or represented visually some way, like a table. So quickly I just set up a table here. On the left hand side we just have a row that's dedicated to a can and a row that's dedicated to bottles, and then a total row, because we only are working with cans and bottles, so we only need 2 rows, one for each. And then we have a few columns that we need to represent. First of all, the refund per item. So what that means is how much of a refund you get per can and per bottle. And then we have another column that represents the number of items. So the number of cans and the number of bottles. And finally, the amount of money raised per can and per bottle. So using the information from the situation in the text and the words above, we're going to fill in this table. So we know that the school receives 5 cents for a can. So in our refund per item, we know that they're going to receive 5 cents. We can also see next to it that they will receive 10 cents for the bottle, or for every bottle. So once again, their refund is 10 cents per bottle. And the total row does not apply to this refund per item column, so we'll just leave that blank. Next we look at the number of items, so the number of cans and the number of bottles. Now we have to remember we're creating a linear system to model this situation, so technically this information would not be given to us. That information is there just to verify, to make sure that our linear system is correct. So without looking at this information there, we only know that there are 2,000 cans and bottles in total. So right off the bat we can say total 2,000. There's 2,000 items. But since we don't know how many cans and how many bottles there are, we are just going to represent these with letters. So we're just going to represent it with a C. For can, we don't know the actual number of bottles, so we're just going to represent it with a B. So we just need to fill in the last column now. The only thing that's left in our text situation at the top here is this $140. So a school raised a total of $140 with all this recycling. Money raised, we know the total right off the bat is $140. Now, the money raised per can, we still don't know that, but we do know that you get 5 cents per can. So it's actually 0.05 C. And the same thing with bottles. We don't know exactly how much money the bottles brought in, so we're going to represent it by combining the refund per item with the actual number of items. So 0.10 B. So now our table represents all the information that we were given. Now you might notice this table is a little bit easier to pull out a linear system than maybe the text above. So you can see here we have C, cans and bottles equal a total of 2,000. And then we have a total amount of $140 raised from cans and the bottles. So right here, if we just look at these and we add these two, total means equal, we now have a linear system. To rewrite it so that it makes sense, we have C plus B equals 2000, and we have 0.05c plus 0.10b equals 140. So here we have a linear system that represents the information that was given to us above. So now we're going to verify to make sure that our linear system is correct, and this is where this information now comes into play. We know that now they collected 1,200 cans in 800 bottles, so we now know the amount of cans and the amount of bottles. We initially didn't know that when we were creating a linear system. So if we weren't given this information previously, in order to verify this linear system, we would just have to do basically trial and error, or guess and check. We'd have to guess until we came up with these numbers. But since it's given to us, it's just going to allow us to verify it much more quickly. So to verify, what we're going to do is we're going to substitute C, cans, equals 1,200, and we're going to substitute B equals 800 to represent our bottles. And we're going to do that for both equations. So when we have C plus B equals 2000, if we substitute, it's going to look like cans, 1200, plus bottles, 800, equals 2000. Remember, we always want the left side to equal the right side. So 1200 plus 800 is 2000 equals 2000. That looks good because the left side equals the right side. And we're going to quickly verify our other equation by substituting the same values. So we have 0.05c, which is cans, so that's 1200, plus 0.10b, which is our bottles, which is 800, and we want that to equal 140. So we're looking to have the left side equal the right side again. So 5 cents times 1200 cans will give you $60, plus 10 cents times 800 bottles will give you $80. So 60 plus 80 equals 140. So our left side, 60 plus 80 is 140, equals our right side, which is 140. For both equations, our left sides equal our right sides. So we know that our linear system that we created from our table of information is correct.